Hello everyone, this is Nathan Liu. I am a ninth grade student at the Harker School. In the next couple of minutes, I'm going to introduce you to my project, using AI to distinguish between human and naturally caused fires. This project won us the Synopsys Science Research Championship in 2020. This all started about 2 years ago. We were experiencing fires in California, and these wildfires tragically caused many people to lose their hard work, uh, hard-earned property and lives. Let me quickly show you a video which I created 2 years ago to support a fundraising for California wildfire victims. Since then, I've been thinking about how I can do something from a scientific perspective to further help prevent wildfires. That is how this project's idea came from. The objective of our project is to lessen the amount of destruction of these fires by predicting whether a fire is natural or human caused. If we know which area of the United States has more natural or human fires, we can prevent them more efficiently. We, we then did some research and we learned that all natural fires are caused by lightning. Human fires have many causes, such as unattended campfires, cigarettes, arson, power lanterns, etc. We investigated some projects other people have done regarding fires, and we found that people have tried to predict when and where fires will start. We decided to take a different approach. By knowing which areas had more human-caused fires than natural fires, we can prevent them before they even happen. We found 1.8 million US fire data points from the past 24 years. This data includes when the fire started, when it was contained, the size of the fire, and where it happened. This is saved on a SQL database file. We used Colab to load the data and run our random forest model. We divided our data into training and testing sets. 80% of the data was for training, 20% was for testing. We tried different numbers of trees and depths of trees in the random forest model. We tried different numbers of trees from 10 all the way to 90, with random intervals of 20. Turns out the accuracies were extremely similar, so we selected 30 as our number of trees because it took less time to run. We then changed the depth of the trees, and the trees had 30 layers, resulting in the highest accuracy of 92.69%. The reason too many layers result in a lower accuracy is overfitting. Turns out, just using the day, it was discovered and latitude and longitude were enough to yield a high accuracy of 92%. Then we added a section in our code that puts the result into a map that plots the data into the places it predicts, with the red dots representing human-caused fires and blue dots representing naturally caused fires. The larger the size of the dot represents a larger fire, so the size of the dot represents the magnitude of the fire. The results in the tests were put into the map and then displayed. Throughout our research, we found which variables matter more than others. For example, longitude and latitude are more important than the year of the fire. If our fire engine finds out that the fire is located in the middle of a forest, the chances of it being a natural fire is much higher. However, if a fire is found in the middle of a city, the chances are it is being human-caused fires. As mentioned above, we use a decision tree in our AR engine. The results showed that most natural cause fires or in areas with wildlife. We concluded that with the correct data collected, any fire can be identified as human or naturally caused with high accuracy. Our AI engine that can determine if a fire is human or naturally caused, 92% and above accuracy, proves that the previous statement is true. If I have chance to continue this research, I would add weather data, such as lightning, and satellite data to increase accuracy significantly. Using weather and satellite data, steps could be taken towards even more accurate predictions of future fires. Finally, this is me and my teammate, Alex Go. Thank you for listening to my presentation.